Hello, my dear students. How are you all? Good morning. Hope you are all doing well today. Today, we'll learn about a very important topic. Chapter 4, Periodic Table. And our today's topic is periodic properties of the elements like radius, atomic or ionic radius, ionization energy, electron affinity, and electronegativity. All these topics are very much important for your SSC, HSC as well as admission students. So no more waiting, dear students. Let's start our today's topic. Before entering our main discussion, we should learn about Coulomb's law. And we also learn what is the relation between Coulomb's law and our today's topic. So now let's start our Coulomb's law. This is an atom. This is nucleus. Nucleus has proton and outer shell has electrons. Let the charge of the proton is Q1 and charge of the electron is Q2. And D is the distance between nucleus and valence shell. That means outermost shell. F is denoted by the attractive force between nucleus and valence shell. That means outermost shell. Now, what is Coulomb's law? Coulomb's law is F is proportional to Q1 Q2 by D square. That means the attractive force between nucleus and outermost shell is directly proportional to the product of charges of proton and electrons and inversely proportional to the square of the distance. That means when the distance between nucleus and outer shell increases, the attractive force between nucleus and outer shell decreases, and with the increase of the number of proton and electron at nucleus and outer shell, the attractive force between nucleus and outer shell increases. Now we should know the relation between Coulomb's law and the radius, ionization energy, and electronegativity, electron affinity, etc. This is a part of a periodic table. In this periodic table, this is group 1A, this is group 2A, and this is period 1, this is period 2, and this is period 3. What happened when you move down in a group? We see from this electronic configuration, all the elements of group 1A has one valence electron. But the number of shell of hydrogen is 1, lithium is 2, and sodium is 3. So when you move down in a group, number of shell increase by 1. So the distance between nucleus and outer shell increases and the radius is increases. And attractive force between nucleus and outer shell decreases. So my dear students, this is the relation of increasing atomic radius and Coulomb's law. Now what happens when you go left to right in a period? From this periodic table, portion of periodic table, you see that every atom or element in period 1 has only one number of shell, and every element of period 2 has two number of shells, and period 3 has three number of shells. That means when you move left to right in a period, number of shell remains the same, but number of proton increase by 1, 3, 4, 5, 6, 7, 8, 9, 10, and number of outer shell electron also increase by 1. Lithium has only one outer shell electron, beryllium has 2, boron has 3, and neon has 8. So when you move left to right in a period, number of shell remains the same. That means the atomic size will be almost same, but with the increase of proton in nucleus and outer electron in outer shell, Q1 Q2 is increases. With the increase of Q1 and Q2, attractive force between nucleus and outer shell also increases. So outer shell comes closer to the nucleus and atomic radius decreases. So my dear friends, that's how we relate Coulomb's law and atomic radius in period and group. Now we see from the above discussion, atomic radius increases when you move down in a group and atomic radius decreases when you move left to right in a period. Now, how can we represent when how can we represent in your answer step why atomic radius increases in groove from top to bottom? When you move down in a groove, a new energy level added. Number of outer shell electrons remains the same. For group 1, all the elements has one number of outer shell electron. From the Coulomb's law, we see that the addition of new energy level results in the increase in the size of the atom and increase the atomic radius. And the attractive force between nucleus and outer shell decreases because d, that means distance between nucleus and outer shell, increases with the increase of number of shell. So that's how we write in your answer state. When you move down in a group, the atomic radius will be increased. What happened when we move left right in a period? The number of shell remains the same. When you move down left right in period, number of shell remains the same. Number of outer shell electrons increased by 1, 2, 3, 4, 5, 6, 7, 8. The attractive force between nucleus and outer shell increases. How can we say that? From Coulomb's law, we say that we see that with the increase of proton in nucleus and outer shell electron, the attractive force between nucleus and outer shell increases. That's why the attractive force increases from left to right. Outer shell electron come closer to the nucleus because attractive force increases and the atomic radius decreases. So, my dear friends, that's how we write in your answer script when you ask why left to right in a period atomic radius decreases. Now, what is the relation of ionization energy and atomic radius? First, we should know the definition of ionization energy. Ionization energy is the amount of energy required to remove electron from outer shell outer shell in its gaseous state and transform it into positively charged ion. That means if we need more energy to remove electron from outer shell of an atom, the ionization energy will be higher. And if we need less energy to remove electron from outermost shell, the ionization energy will be lower. So as we move down in a group, the atomic radius increases. So we need less energy to remove electron from outer shell because the attractive force between nucleus and outer shell decreases according to Coulomb's law. That's why the ionization energy decreases from top to bottom in a group. Let's see how you represent in your exam. A new energy level is added when you move down in a group. A new energy level is added. Number of outer shell electrons remains the same. Addition of new energy level results in the increase of atomic size. That means the distance between nucleus and outer shell increases. An attractive force also attractive with the increase of atomic size, the attractive force decreases. And we need less energy to remove electron from outer shell. That's why ionization energy decreases from top to bottom in a group. And when you move left to right in a period, what happened? Number of shell remains the same. Number of valence electron increased by 1. With the increase of proton and electron, the attractive force between nucleus and outer shell increases. Outer shell comes closer to the nucleus, and we need more energy to remove electron from outer shell. That's why the ionization energy will be increased. Now there is some exceptional case. These are the exceptional case. In my next slide, I will explain why this happened. So before knowing the exceptional case, we should know the stable electronic configuration. S2, P3, P6, D5, D10, half filled and full filled. S orbital has only one stable electronic configuration is S2, and P3 half filled, P6 full filled, D5 half filled, D10 full filled, F7 half filled, 14 fulfilled. These are stable electronic configuration. If an element has stable electronic configuration, their ionization energy will be higher because they need more energy to remove electron from outer shell. For this reason, between sulfur and phosphorus, sulfur should be more ionization energy. But when you see the electronic configuration of phosphorus and sulfur, phosphorus is stable electronic configuration, half filled p orbital. So we need more energy to remove electron from phosphorus, outer shell electron of phosphorus. So the ionization energy of phosphorus will be higher than sulfur. In the same way, we can rearrange these elements according in order of their in increasing order of their atomic radius and ionization energy. So we know from our previous lecture that the ionization energy increases from left to right in a period. So the ionization energy of magnesium, aluminum, silicon, phosphorus, and sulfur should be like this. But from this electronic configuration, we see that magnesium and phosphorus have stable electronic configuration. So ionization energy of magnesium is higher than aluminum. So magnesium should be placed here and aluminum should be placed here. On the other hand, phosphorus and between phosphorus and sulfur, phosphorus has stable electronic configuration. So the ionization energy of phosphorus is higher than sulfur. So phosphorus should be placed here and sulfur should be placed here. And the correct order of increasing order of ionization energy will be like aluminum, magnesium, silicon, sulfur, and phosphorus. In the same way, we can identify which one is more ionization energy. The element which has stability in configuration has higher ionization energy. Between silicon and arsenic, arsenic has stability in configuration. So arsenic ionization energy of arsenic is higher than selenium. So my dear friends, no worries, just write down the electronic configuration and rearrange according to your knowledge. Now we want to learn our next topic, electronegativity. The ability of an atom to attract electron towards itself is called electronegativity. So actually the ability of an atom to attract the covalent bonded pair of electrons toward itself to form partial negative and partial positive charge. Now, this is also the reverse of atomic size, because if the atomic radius or atomic size is decreased, the element can attract the electron pair, bonded electron pair, more frequently, more easily. So, from left to right in a period, atomic with the decrease of atomic size, and electronegativity will be increased. And from top to bottom in a group, with the increase of atomic radius, the electronegativity will be decreased. Now, how can we express, how can we write this in your answer script? When you move down in a group, number of valence shell electron remains the same, number of energy level added. So the distance between nucleus and outer shell increases and the attractive force decreases. So the tendency to attract the electron pair also decreases, and thus that's why the electronegativity also decreases from top to bottom in a group. When you move left to right in a period, number of shell remains the same, number of outermost shell electron and proton increased by 1. So the attractive force between nucleus and outer shell increases according to Coulomb's law. So the element can attract electron pair more tightly, more vigorously. That's why the electronegativity of an element increases from left to right in a period. So, my dear friends, here we see some example. The numerical value of electronegativity of lithium is 1, aluminum 1.5, chlorine 3. That means from left to right, electronegativity increases. And from top to bottom, fluorine, chlorine, iodine, electronegativity decreases. Fluorine 4, 3, 2.8, 2.5. So, my dear friends, we can explain it easily. Now, we should know the electron affinity. This is our last topic. Electron affinity means the amount of energy released during an addition of extra electron to an atom of an element in its gaseous state, transform it into a negative ion, is known as the electron affinity of that element. That means the elements which can attract the electron, which can accept electrons more vigorously, electron affinity of that element will be higher. So with the decrease of atomic size, the electron accepting power will be increases. That's why the electron affinity increases from left to right in a period. And when you move down in a group, the atomic radius increases. The outermost shell electron go far away from the nucleus. So electron accepting power decreases. That's why the electron affinity of element decreases from top to bottom in a group. Now, how can we write in your exam paper when you move down in a group, number of energy level added to the atom, a new energy level added to the atom, number of outer shell electrons remains the same, addition of new energy level results, an increase of atomic size, and these also increase the atomic radius. And with the increase of atomic radius, the electron attracting power also decreases. That's why the electron affinity is decreases from top to bottom in a group. Now, what happens when you move left to right in a period? Number of energy level remains the same, but valence shell electron increased by one, and number of proton increased in a nucleus. So the attractive force between nucleus and outer shell increases. Outer shell comes closer to the nucleus. With the increase of attracting power, as accepting power of electrons, the electron affinity increases from left to right in a period. That's how we write in your answer script. Now, there is some exceptional case between fluorine and chlorine. The fluorine should be higher electron affinity, but between fluorine and chlorine, chlorine is electron affinity of chlorine is higher than fluorine. This is an exceptional case. Now we know why electron affinity of chlorine is higher than fluorine. From this two electronic configuration of fluorine and chlorine, you see that chlorine has 7 electrons in its third shell and fluorine has 7 electrons in its second shell. So the electron density of fluorine's second shell is higher than chlorine's third shell. So additional electron when come closer to third shell of chlorine, the repulsive force will be lower than the second shell of fluorine, because the second shell of fluorine has higher electron density. Small size 7 electrons, big size 7 electrons. So chlorine accept electron before fluorine. That's why the electron affinity of chlorine is higher than fluorine. Another exceptional case is oxygen and sulfur. Oxygen should be higher electron affinity, but sulfur accept electron first. So between oxygen and sulfur, electron affinity of sulfur is higher than oxygen. Here is the same explanation. Sulfur has 6 electron in its third shell and oxygen has 6 electron in its second shell. So the electron density of second shell of oxygen is very much higher than electron density of third shell of sulfur. So when another electron comes closer to third shell of sulfur, it accepts easily because electron density is lower. So repulsive force don't work here. But in case of oxygen, the electron density of the second shell of oxygen is very much higher than third shell of sulfur. So when another electron, we try to push another electron in second shell of oxygen, the repulsive force will be more than attractive force. So sulfur electron accept easily before oxygen. That's why the electron affinity of sulfur is higher than oxygen. So, my dear friends, now in a short way, we understand our today's topic. When you move down in a group, the electron shell increase by one, and number of and from left to right, number of electron shell remains the same. Valence electron, last shell electron. When you move down in a group, valence shell electron remains the same, but when you move down left to right, valence electron increase by one. With the increase of proton and electron, the attractive force increases. That's why the atomic radius decreases from left to right. And electronegativity, ionization energy, and electron affinity, these three topics are inversely proportional to atomic radius. So with the decrease of atomic radius, electronegativity, ionization energy, and electron affinity increases from left to right in a period and decreases from top to bottom in a group, because atomic radius increases from top to bottom in a group. That's why electronegativity, ionization energy, and electron affinity increases from top to bottom in a group. So, my dear friend, I think today's lecture will be helpful for you to understand atomic or ionic radius, ionization energy, electron affinity, and electronegativity. So, try to practice this at home. Don't be hopeless. I am with you. If you have any query, please don't forget to knock me. Stay home, stay safe. Thank you. Allah Hafiz. Assalamu alaikum.